Hello everyone, my name is Nadine Indah Wijaya from 10F, and today I'll be discussing about reflection and interference for my physics project. Before I start explaining about reflection and interference, I'll be telling you guys about our big question and outcome for this term. Our big question is why my visionary leadership cause and or effect transformation. And for our outcome is able to implement phenomena of waves and lights in a physical and geometrical optics phenomenon to provide a future-forward innovation. For this term's project, our project aims to create an engaging video that simplifies the concepts of waves and sounds through real-life examples. So, a simple way to explain what reflection is when a wave strikes an object or a surface that bounces off. So how does reflection work? The reflected light continues to travel in a straight line but in a different direction, and here are a few things that you should remember about reflection. One of them being light is reflected at the same angle that hits the surface. And as you can see, this is the diagram of how reflection works. In the middle you can see a dotted line that is the normal, which is normal, and for the left part it's the incident angle, and for the right part, it's the reflected angle. As a real-life example of reflection every day, you at least look a few times in the mirror to see what you look like. And how it works is, first, it's from the light source. Light from a source such as a lamp or the sun emits photons, aka particles of light, in all directions. Number 2, striking the mirror. When these photons hit the mirror, they interact with its surface. The surface of the mirror is very smooth and microscopic level, so instead of being absorbed or scattered, the photons bounces off the mirror in a predictable manner. And for the third one, which is angle of incidence equal angle of reflection, as you can see also from the diagram, according to the law of reflection, the angle at which the light hits the mirror, which is aka angle of incidence, is equal to the angle at which it bounces off, aka angle of reflection. This means that if you shine a light at a mirror at a 30-degree angle, it will reflect off the mirror at a 30-degree angle as well. And for the last one, which is reaching your eyes, after bouncing off the mirror, the photons travel in straight lines until they enter to your eyes. Your eyes then process this light, allowing you to see the image of yourself reflected to the mirror. So for the next one, which is interference. Interference is when two or more waves meet while traveling in the same medium, aka overlapping waves. So how does interference work? Interference occurs when waves overlap, either strengthening each other, aka constructive interference, or weakening each other, aka destructive interference, creating patterns. It's important in fields like optics and telecommunications. As you can see here, there are the diagrams of what interference look like. As an example in real life of interference, which is noise cancellation headphones, if you combine sound waves by headphone speakers with ambient sound waves, aka noise, which is noises outside of your headphones, if you combine them, it will then become a straight line, which means that unwatched sounds that you don't want will be cancelled out. So the next one, which is the examples in other fields other than physics for reflection. The first field, which is the medical field, when doing an ultrasound. The ultrasound machine sends out high-frequency sound waves through a probe. When these sound waves encounter different tissues and structures in the body, they are reflected back to the probe at varying degrees. Dense tissues like bones reflect more sound waves, whereas softer tissues reflect fewer. And for the other example, which is architecture, modern architecture often incorporates reflective glass to control the amount of sunlight entering the building. This not only helps in regulating indoor temperature, but also reduces glare and enhances aesthetic appeal. And for the examples in other fields for interference, the first field, which is biology. In genetics, interference refers to the phenomenon where the occurrence of a crossover event between two genes affect the likelihood of another crossover nearby. This phenomenon is observed during meiosis. The other example is communication. In communication systems, interference can occur when unwanted signals disrupt the transmission or reception of desired signals. This interference can be caused by various factors, including noise, other signals, or environmental conditions. And last but not least, to answer the big question, my answer is a visionary leader sparks big changes by bringing fresh ideas, speeding up transformations, and making order out of chaos, much like how energy drives changes in physics. And that's it for the video. Thank you for watching, and I hope that you have learned something about reflection and interference from this video.